Okay, so today is a little different type of notes. On Tuesday and somewhat yesterday, we talked about exponential growth and decay graphs. Okay, what the exponential growth graphs look like, if I come off to the side here, what those graphs look like is as they continued, we keep getting bigger and bigger and bigger super, super fast, right? And then exponential decay, what happened? It got smaller, smaller, and smaller really fast, right? It was kind of the opposite. So today we're actually going to be connecting them to specific problems and finding the answers to specific values with these. Okay, so up at the top of your notes, go ahead and label it exponential growth and decay. Okay. With these comes an equation here. So exponential growth, exponential growth. Okay, obviously with growth, are we getting bigger or are we getting smaller? We're growing, we're getting bigger, right? So what this equation looks like is we have y equals a times 1 plus r to the t, and I'll explain all of that here in a second. And then exponential decay looks very similar, but with decay, are we still getting bigger or are we getting smaller? We're getting smaller, right? So that changes our equation just a little bit. It turns into a times 1 minus r to the t. Looking at those two equations, what's the one difference between them? It's the sign, right? For exponential growth, we're adding whatever that percentage is. Exponential decay, we are subtracting whatever that percentage is that we talked about yesterday. So let's talk about what those letters mean there. So A, we kind of talked about this on Tuesday and yesterday. A stands for our initial amount. What do I mean by initial amount? What does initial amount mean? It's the amount I start with, right? So our initial amount, or A, that's the amount that we start with. Okay? What does R stand for? I'll tell you this. R stands for rate. Rate normally comes in a percentage. Okay, rate is how much something is changing over time. Okay, so we can say we are growing 20% in population every year. I don't know if that's true. Don't take my word for it. Okay, but that's what it means by the rate. We're talking about a specific percentage of how much it's growing or how much it's decaying by. And then T, what do you think T stands for? T can be in years, in months, in number of times. Time. T stands for time. Do you agree if I know all three of those variables, I can plug them in and solve? Yeah, because here, this Y, that just stands for what I'm looking for. Okay, so we are going to look at a bunch of different examples today talking about exponential growth and decay. Okay, so do you agree these equations are very similar to each other? Yep. All you got to do is just figure out, okay, am I growing or am I decaying? Okay, we're going to talk about how to see that here. So, looking at example 1, again, don't write this whole problem down. We're just going to talk about it. Okay, so it says a company comprises to release a new smartphone model every month. Each model's battery life will be 6% longer than the previous models. If the current model's battery life is 641 minutes, what will the latest model's battery life be 5 months from now? First thing we need to figure out, is it growth or is it decay? How we figure that out is we want to look at the rate. What is the rate? What did we say rate stood for? Percent. What's our rate here? 6%. Okay, we want to look for key terms if it's telling us we're growing or decaying. So let me read that sentence again. Each model's battery life will be 6% longer than the previous. What's a key word there? Than the previous, this right here, longer than the previous. So am I increasing or am I decreasing? I'm increasing. So is that growth or decay? Growth. Go ahead and write the word growth on your notes. Key word for that, increasing. Or sorry, yeah, put increasing. Okay. Any word that can mean increasing, you're going to know growth. Okay, so what we're going to do is we're actually going to solve for what this is, and you can take these notes. So we need to find those three variables. What is my A, my initial amount? What's the initial amount that we started with? 641 minutes. What else do I need to find? What was the next one? The rate. What is my rate? It is 6%, but what we have to do with this is we have to turn it into terms of 100. Okay, so we need to take this and divide it by 100. I'll show you a trick here. So do you agree if I turn this into a decimal, this is 6.0? Okay, what I want to do is I want to move this 2 decimal places to the left. Okay, or you can type that in your calculator and divide by 100. Okay, so my rate is 0.06. Star that. Star rate for me. Because you know you have to change that rate and divide that by 100. Okay, and then what was the last thing we needed to know? Time. What is time? 5 months from now. Yep. So now we use the growth function, which I gave you up above. Is it adding or subtracting? Yep, for growth we're adding. So now let's plug in those values here. We have y equals, what was A? 641. What was R? 0.06. And then T? Yep, is that times 5 here or is it something else? It's to the 5th power. It's that exponent, right? So, before you can start typing this in your calculator, what do I need to do first to simplify a little bit? Yep, let's put that together. So we get y equals 641 times, if I add these two together, I get 1.06 to the 5th power. Everyone grab a calculator. Okay, when I'm typing this in my calculator, what am I going to type in first? Parentheses and what's it to? The 5th power, yep. So in your calculator, type 1.06 to the 5th power. Yep, keep that number in your calculator because you should get 1.338 blah, blah, blah. What is the last thing I need to do? What am I going to do with that 441 or 641? Multiply, yep, because we're multiplying here. So take that number in your calculator times 641. What do you get? Yep, so you get 857.8. I'm not going to be picky about how you round your answers today. Okay, but when you do your worksheet for me, I want to see 2 answers. I want to see your function that you came up with and your answer. Okay, which that should come naturally from your work, right? Okay. Okay, this one. I want to see, it says an employee receives a 3% raise once per year. Are we increasing or are we decreasing? What gives it away that it's increasing? It's a raise, right? So are we doing growth or decay? Growth. And let's talk about our values. What is my initial amount? 75,200. What is my rate? I agree with you, it's 3%. What do I have to do with that, though? I have to move the decimal or divide it by 100, so I get 0.03. And then lastly, what's time? 6 years. Okay. Again, since it's growth, which equation are you going to use? Are you going to use the addition one or the subtraction one? The addition one. Okay. Number 5, it says, for tax purposes, a car rental company assumes each car in their fleet depreciates by 9% per year. What do we think? Growth or decay? Why? What's the key word? The depreciates. Does that sound like we're increasing or are we decreasing? That's decreasing. So we're going to use decay this time. Okay. Does decay change how I find my A, R, and T? No, you still find them the same way. What's A? Yep. What's my rate? And real quick, just for some practice, I want to change this to 12%. Okay, so if my rate is 12%, what am I changing that to? Right. I'm going to move that decimal 2 places. Okay, so that turns into 0.12. Or you can type in your calculator 12 divided by 100 to double check that. Okay, and then T, 10. Okay, let's do one more practice with using the equation. So since it's decay, what equation am I going to use? Addition or subtraction? Bingo, yep. Okay, so we're plugging in values at this point, right? So A, we said, was 34,600. And then we have 1 minus what? 0.12, yep. And then to what power? 10. Remember, that's a power, make sure. Okay, what do I need to do first here? Parentheses, take 1 minus 0.12 in your calculator, what do you get? Yep, so this turns into 0.88 to the 10th power. Okay, I want to see this for sure, along with your answer. How do I calculate the answer on this? What do I do first? Yep, 0.88 to the 10th power. And then multiply that by the A. Yep, 34,600. What do you guys have in your calculator? Yep. And then again, I'm not going to be too picky on how you round here. Yep, let's go through that again. So on your calculator, I want everyone to try just so we're making sure we're getting the same answers. Capiche? Okay. All right. First thing, take 0.88 to the 10th power. 0.88 caret 10. Hit equals. In your calculator right now, you should see 0.2785. Okay. Nope, just leave that in your calculator. And then once you have that number, which again should be 0.2785, what do you do with that now? Multiply it by your A value. So times 34,600. In your calculator, you should have 9,636.13.